Hi everyone, today I'm going to discuss a search for improved performance in regular expression. The aim of this research is to find automate performance improvement to reduce the running time of program while maintaining or improving functionality. And genetic programming is used to discover the performance improvement of a series of target programs in regular expression, which represents the first application of automatic software improvement to runtime performance in regular expression language. The figure below shows the logic of genetic programming. The study strategy. This experiment is to evaluate how genetic programming can be used to improve the performance of rejectors in terms of minimized execution or work time. This work described as a pilot study in the domain of automated regular expression improvement, which formed a basis for future work in the area. They also study overview of the background to both regular expression and software improvement. In their methodology, include the approach to population seeding with target solution and a detailed description of the fitness solution. So, in the experiment are outlined in the benchmark test result of target rejectors for improvement in detail. In their experiments, they are using PoEG2. They use grammatical evolution as implemented in the PoEG2 evolutionary framework. In order to make regular expression amenable to evolution in PoEG2, a GE-compatible LR parser was constructed for this application. So the next point is all experiments use PoEG2 with experimental parameters as summarized in Table 1. They constructed and conducted a single 1 to 1,000 generations for each problem to find some interesting background example of their rejectors. The first problem is rejected problem set. They have assembled a benchmark set of rejected examples. These rejectors can be considered toy problems in that they are relatively short and understandable. The whole problem set can fit in this research and do not pose a significant scaling challenge for GP. So, in the experiments, also need to consider the input test data putting. Functionality error is sum of match error. To explain the test of input string, they use a very basic approach to automatically generate an additional test case for each rejection. They take an input string and a loaded target rejected which matched the desired test. They modify this input string until the target rejected no longer matched. So, the result of a single genetics program runs with a population of 1,000 and 1,000 generations. Improvements were found in all rejectors in their test statistics as can be seen by the speed up list in Table 3. They classify this improvement as specialization, as each rejector is specific to the input test case they used. The speed up values are indicative of typical improvement that were found for their chosen input data set. So, example of improved rejectors is shown in Table 4. The example appear compassed as mutation has introduce what they consider noise. Changes which have no measurable impact on one-time performance. From this result, they can see that improvements are possible, but the result has become less readable. From this result, it would appear that the improvement requires more than a single modification of a problem. In other performance improvement work on much larger programs, the numbers of change to a program appear to result to less than a dozen change amongst approximately 2009 of source code. So, in the table 5, all improvement rejected from a genetic program 1 as sold as for catastrophic problem. While the difference between the first two rejected clearly showed a 70% reduction in execution time, the performance improvement thereafter are not obviously. So they found a statistically significant difference between reject 2 and 3. Under further repeat the test, compare rejected 3, 4, and 5 in the table 5. No statistically significant differences was found between the running time of this regular expression. This highlighted a limitation with this approach, whereby one-time performance variability can result in mutation. So they have two research questions. This research question regarded the topic of performance improvement of regular expression using a population-based evolutionary search algorithm, which raises an interesting question. So the first question is it possible to get all the regular expression from the source response tree? This answer to the first question, as they really found the rejected in the wow, for which they can find some performance improvement. The second question is it possible to generate a grammatical difference solution while maintaining functionality? As their second research question as to whether or not they can maintain functionality, they are somewhat undesisted. For the soft rejected, they were able to find improvement, but these improvement clearly did not maintain equivalent functionality. For more complex rejected, they they found improvement, but cannot say for sure if these improvements affect the functionality. So they also have good analysis. They have presented and experimented with a complex benchmark test suite of real-world rejected example. And then the first one is a complex benchmark test suite of real-world rejected example, which means that they also demonstrating the utility of grammatical genetics programming. And their evolution demonstrated the utilities of grammatical genetics programming in exploring the chain between functionality and performance. They were able to find improvement in code from widely used systems. And then the second point is demonstrating the utility of grammatical genetics programming. They also have one drawback. There is not easy to understand regular expression after modified by genetic programming. So they have to consider rejected caprice could be continuously gathering as they are processed from human written example as well as over the course of evolutionary runs within a genetic programming content. This library could be used to drive a semantic crossover operators. And then the last one is in the future they have to provide more bang for buck to the programmer. Thank you for your watching.